So in this video, we will look at vector component of vector u orthogonal to vector v. So let's say the component of vector u orthogonal to vector v is given by this formula, which is the vector u minus the projection of vector u onto vector v. So means that you need to find the projection of vector u onto vector v first, and then we use the vector u minus the projection. So based on this one, so let's look at this exercise 5. Let's say let vector u is equals to 2, 4, and 2, and vector v is equals to 1, 2, and -1. So the question is, find the vector component of vector u orthogonal to vector v. So here is the formula. What we should do is we use the vector u minus the projection of vector u onto vector v. So means that first we have to find the projection of vector u onto vector v. So if you still remember, the projection of vector u onto vector v is equals to the dot product of vector u and vector v divided by the magnitude of vector v squared multiply with the vector v. So we need to find this one separately. Then we substitute in the formula of projection of vector u onto vector v. So let's start with the first one. Vector u, the dot product of vector u and vector v. So vector u is 2, 4, and 2. And the vector v is 1, 2, and -1. So the dot product will be 2 times 1 plus 4 times 2 plus 2 times -1. So here we have 2 plus 8 minus 2. So here we have 8. Next is the magnitude of v. So the magnitude of v will be equals to square root of. So where the coordinate of v is 1. So 1 squared. Plus here we have 2. 2 squared. Plus finally is -1 squared. So from here we have square root of. Here is 4 plus 1 plus 1. 4, 5, and 6. Square root of 6. So by substitute into the formula of projection of vector u onto vector v. So projection of vector u onto vector v is equals to first the dot product, which is 8 over square root of 6. Don't forget we have squared here. And then multiply with the vector v. So vector v is 1, 2, and -1. So here is 8 over 6, 1 times 1, 2, and -1. So here we have 4 over 3 times 1, 2, and -1. So here we can write as the form of 4 over 3, comma, here we have 8 over 3, comma, -4 over 3. Or you can write in the form of I, j, and k, which is 4 over 3i plus 8 over 3j minus 4 over 3k. So this is the projection. So in order to answer the question, the vector component of u orthogonal to v. So therefore, the vector component of u orthogonal to vector v, the formula is vector u minus the projection of vector u onto vector v. So where our vector u is 2, 4, and 2 minus the vector of projection of vector u onto v is here 4 over 3, 8 over 3, and negative 4 over 3. So finally we have 2 minus 4 over 3 will be 2 over 3. And then 4 minus 8 over 3 will be 4 over 3. And finally 2 minus negative 4 over 3. So 2 minus negative 4 over 3 will become 10 over 3. Or you can write in the form of 2 over 3i plus 4 over 3j plus 10 over 3k. So here is the solution for this exercise.